Okay, so there was a change in the program. So Joana Simões will now present us the data ingest API of GeoServer. Thanks.
Okay, thank you very much. Good afternoon. I'm going to talk about the data ingest API. But first, let me tell you about the OpenGeo portal. So to give you a little bit of context, the OpenGeo portal is a framework for browsing and downloading geospatial data from repositories, so typically from universities. And the core members of this project are actually the universities which have very large collections of data sets. So the project has arisen from this need of sharing metadata and also data between different institutions which had different infrastructures. And to do this through standards. So this is an example of an implementation of the OpenGeo portal in production for Tufts University, which is one of the universities that led the development of the OpenGeo portal. And let me tell you a little bit about the architecture. So as you can see here, it's a modular architecture, which is very interesting. So on one hand, you have the repositories from all these universities. Then they are harvested by the OGP harvester, and they are stored in solar indexing. And so the OGP discovery tool accesses solar and retrieves queries and retrieves these data sets, this information. The user, the final user, explores this system through a web portal very similar to the one I show you in the previous screenshot. So the data ingest API fits as it's another component of this system, which extends it to deal with the data along with metadata. So basically, it's another loosely coupled service which extends the capacities of the OGP and allows it to manage data which is stored in a GeoServer. So that was the idea. And the interesting thing in this system is that you can manage data along with metadata, as I'm going to show you later, which I think is something rather unique. Another interesting thing about the data ingest API is that it is a simple service, so it does very limited number of things, and it's REST. So it exposes the REST API. So these are two characteristics which make it very easy to integrate into a microservice architecture. So it's technology agnostic. So although this API is developed in Java, you could integrate it with other services that are developed, for instance, in Python, through the use of the REST API. And you can see here, this is a diagram taken from the Docker composition, which implements this system. So I don't need to explain it in detail, but just to let you know that there are many different components and they interact. They are all articulated together to create this framework. So how many people here are Java developers? Can you raise your, okay. So there are a couple of people here, not many. So you probably know, the people who are Java developers probably know the Spring framework. We used Spring Boot for this project. And I show here on purpose these annotations because they are very useful. They allow us to inject certain behavior in the code which in previous versions of the Spring Framework you had to configure using XML files. So now basically it's very easy, it's quick and easy to build a web application, a very solid web application, just through the use of these annotations. And regarding the geospatial libraries, we are standing in the shoulders of giants. So we are using the GeoServer Manager to interact with GeoServer. It's a library developed by GeoSolutions, which allows you to interact with the REST API of GeoServer. And some things that we do are not directly related to GeoServer, but for instance, we do things like checks on shapefiles, as you can see in this code snippet. And for that, we use GeoTools, which is a general purpose geospatial library. So basically, these two libraries made it possible to develop the data ingest API. So what does the data ingest API provide? So basically, as I said before, it's a very simple REST interface, which allows you to do a couple of things. So to upload data into GeoServer, to update data, and to download data, also to unregister data, and then to do some queries like listing the data sets or describing them. So it's really 2 or 3 things. What is interesting about this library is probably the scalability capacities, because as I mentioned before, this library was designed for universities who have very large repositories. So they have a large number of data sets, but they also have large data sets, if we can say big data. And with that in mind, we design a couple of strategies to be able to manage this sort of use cases. So I would say this is one of the strengths of this library. And then the online documentation is also is very comprehensive. Is generated using the Swagger, which is a framework for documenting REST APIs. And thanks to that, it makes it really easy to use. I'm going to show you later. So what does the data ingest API not provide? I mean, basically everything else, all other types of interactions that you want to do with your server, like for instance, creating workspaces, reprojecting data sets, all these sorts of things. If you are searching for all other things apart from the 2 or 3 things that I described before, then you're better off using GeoServer Manager or even the REST API of GeoServer directly. It also does not allow to work currently to work with anything but vector data. So it's really quite limited what it does, but that was the idea, and in a way it's designed as a microservice. So I wanted to tell you about the OGP harvester because this is a good example of how you can use the data ingest API. How can you really put it into practice? So the OGP harvester is an application which supports scheduling harvesters. And using this, an organization can build their own custom metadata catalog using only selected metadata. And the data ingest API extends this functionality, enabling the user to also browse the data along with the metadata. So, in one hand, if you want to download the data set, it will search for the accompanying metadata on the Solar registry, if it exists. And if you want to upload a data set, you can create a zip package with the data and metadata, and the system will send the metadata to Solar and the data to GeoServer. So I think what is really interesting about this entire system is that you can deal with data and metadata together. You can really link them. This is an example of the user interface to download data and metadata. And this is an example of the user interface to upload data and metadata. So I'm not going to go into too much detail regarding the implementation. If you want, you can ask questions later, or you can grab me in the coffee breaks. But I wanted to call your attention to some aspects related to what I said before, so to the robustness towards large data sets. So the fact that we have to deal with these scenarios where we have very large data sets, or we have a high number of data sets. And we use a couple of strategies. I mean, one of them is pagination. So by default, when you list the data sets, you get a paginated result. You get one page. We also use asynchronous requests, both for download and upload, so you can have concurrent users, and you don't need to block the system when you are having a request. And finally, the most interesting one is the cache. So we cache both the HTTP response. So when you have the list of data sets, this is a cached response. And we also cache the files, the physical files. We have a cache on disk. So if you are downloading a very large data set, you don't need to be requesting it all the time to GeoServer. And another interesting aspect is the security, because we use OAuth 2, which is a standard, and this allows it to integrate very easy with other services. So as I said before, the REST interface uses Swagger. So when you launch the service, it exposes the documentation on this URL, where you have the host where you launch the service, and it looks more or less like this. And for JSON lovers, there is even a JSON version of the documentation. And this is actually, it's actually very easy to try this if you want, because every service was Dockerized, was virtualized, it runs in a container, and there is a Docker composition which does the job of orchestrating all these services. So very easily you can manage to launch, to recreate the entire system in your computer in a matter of seconds. And I wanted to show you this. Uh-oh. Maybe I'm going to... Okay, let's do it like this. And supported view environment. Yeah, I think I even. Do I still have a couple of minutes, or?
Yes, we have a couple of minutes.
Yeah, yes?
Yes.
Okay, so I'll run it from. I thought it would be quite standard to run a video from. Now I think it's... What? Yeah, no, let's just leave it. It's strange that you cannot open videos here, but... Yeah, it seems so. Well, it's an MP4, but... Okay, let's... okay, this was the team behind the development of the Data Ingest API. So Patrick and Chris are from Tufts University, and along with Harvard, they were the developers of the OGP project. And perhaps this is the most important slide. So this project is free and open source. It has a GPL license. And you can fork it or clone it on GitHub. This is the URL. And if you go to this repository, there is a folder called Docker. And in this folder, you will find the Docker composition, which recreates the system, which was what I wanted to show you now in the video. And okay, thank you very much for your time.
Thank you, Joana. We have time for a few questions. Okay. Thank you very much again.
Thank you.
So we'll go to the last talk of this session by Marjorie Robert of IGN France about architecture designed to efficiently process Sentinel-2 time series in R&D context.